the first thing they talk about is angles in the unit circle here. And they talk about angles if you were to place it on the coordinate plane. All right, so we're taking our angles and we're putting them on the coordinate plane. All right, so we have the XY value. Some terms here in standard position, which is your first term in this section. Standard position means you start right here on the x-axis in the positive side. All right, your vertex is on the origin. Your initial side, where you start the angle, is to the right on the x-axis. All right, your terminal side, terminal means ending, right? That's where it ends, terminal side, and that can end anywhere on the unit circle. That can end anywhere on the coordinate plane. Anywhere on the coordinate plane, this can end, all right? It always moves counterclockwise in standard position. Counterclockwise in standard position. All right, so if you have a positive angle, you're going to start here, and you're going to move around until you end, all right? The measure of the angle is how many degrees you moved, all right? How many degrees are in a circle? 360. So you're going to move a certain number of degrees until you get to your terminal side, and that's going to be the degree of the angle. And that's how it always is with angles, right? When we studied angles in geometry, a 30-degree angle was 30-degree movement from one side to the other, all right? That's the difference between the two, all right? And so that is where we're doing, but we are just now putting them onto the coordinate plane. So we're putting angles onto the coordinate plane. Standard position. Initial side is at the x-axis in the positive, and then you move counterclockwise to your terminal side where it ends, all right? So let's look at measuring these angles. Find the measure of the angle to the right, all right? So we have this angle, and they have given us part of it. From here to here is 20 degrees. How does that help us? Why does that help us? The straight line is what? This right here, this part of it is 180 degrees. We know that because a line is 180 degrees. It's half a circle. So then how much is this whole angle here? 200 degrees. We have 200 degrees here. All right. So let's look at this question. One full rotation contains 360, obviously. That's this guy right here. How many degrees are in 1/4? So how many degrees would this be then? 90, right? How many degrees would this be? And how many degrees would this be? 270. All right. That's all we're doing. All right, so standard position says you move counterclockwise for positive angles, all right? So they've given us an example of a 120-degree angle. They have started here. They have moved 120 degrees and stopped. That is a positive 120 degrees. Negative 120 degrees, all right? Negative always indicates movement. This angle is still 120 degrees, right? However way you look at it, it's 120 degrees. The negative just tells us which way we moved, all right? If you see a negative, it means you started right here in standard position and then you went clockwise. That means negative 120 degrees. So like negative 90 would be down here, positive 90 would be up here. Okay, that's the only difference between positive and negative degrees. It's just talking about movement on the coordinate plane. This first one, let's just think logically. Which quadrant is 36 degrees going to be in?
It's going to be in the top right quadrant.
Yeah, it's going to be in the first quadrant. So remember your quadrants, quadrant 1, quadrant 2. Remember those move counterclockwise too, by the way. Just, it's all coming together. Okay, quadrant 3, quadrant 4, right? 36 degrees is going to be in the first quadrant. Why do I know that?
Because
Where's my cutoff for my first quadrant? What degrees? 90, right? So it has to be there. We're sketching, so that means we're not getting out a protractor, right? We're sketching. We're sketching these. So you are going to sketch. 45 degrees is going to be where on this guy? Right in the middle. So 36 is going to be slightly down from there. We're just going to do that. Okay, does that make sense? You are sketching. You're going to be sketching, all right? Now, if you put, I'm not going to get a protractor out either, right? So now if you put him up here, then we're going to have a problem, right? We're going to have a problem. That's 36 degrees like northeast, right? That's not actually 36 degrees standard position. So So the key is that you know approximately where it is on the circle, on the coordinate plane. 315, what quadrant is that one going to be in? The fourth quadrant. Okay, how do I know that? Key positions on this is 90. This is the one we just talked about at that other one. 90, 180, 270, and 360. Those are your key movements here, okay? So if I have 315, first of all, it's going to be smack dab in the middle of that fourth quadrant because it's 45 degrees away from my 270. All right? All right, 45 degrees away. And so, yes, that's an easy one to draw, and that's one you're actually going to get familiar with later on. But it is going to be 45 degrees right there. Approximately, obviously, I'm sketching as well. All right? Negative. Now, when you think about negative movement, you want to do kind of the same concept, but go backwards. This is negative 90. This is negative 180. This is negative 270 and negative 360. Where is my negative 150 going to be? Which quadrant? Third quadrant, right? If this is 90, how far away from this guy is the 150?
Like 2/3.
Right, so it's going to be 30 degrees away from my 180 over here. So it's going to be about right here, probably. And then this guy's going to look like this, right? So we're going to do this to show our movement there. Coterminal angles. Two angles in standard positions are coterminal if they have the same terminal side. That makes sense, right? Coterminal. All right. You can actually have a multitude of coterminal angles because this is a cycle, and you could actually keep going and keep going past 360. But they've given us an example here. 135 degrees, that's positive 135 degrees, will end at the same exact spot as negative 225. Makes sense? Because they add up to what? 60. Yeah. So, and actually you can find its coterminal angle by subtracting or adding 360. If you add an entire circle, you're going to end up where you started from. Makes sense, right? So if I take this and I kept going, I actually could have a degrees larger than 360 that was also coterminal. If I start here and subtract 360, I get that 225. All right, so coterminal angles, the way you find them is by adding and subtracting 360. You add and subtract an entire circle, all right? The unit circle has a radius of 1 unit, hence the term unit circle. They actually use this symbol theta. It's just a Greek letter, so don't get crazy about it. But when you start using trig, this is what they're going to use instead of x. Mostly because x and y typically represent sine and cosine. Cosine and sine, rather. And so you'll see this theta. It's just a variable representing the angle measurement. You should have seen it before when we've done trigonometry in some sense that very often they'll use this as an angle measure. But that's usually the measure of the angle in standard position. The reason it's called the unit circle, the only reason it's called the unit circle is because the radius is the length 1 unit. That's why it's called the unit circle. The radius is 1. So then they start talking about sine and cosine of angles. So suppose the angle in standard position has a measure of theta. The cosine of theta is the x-coordinate, which is the terminal side, and the sine of theta is the y-coordinate. Why is this? So they don't explain it as well as I like it to be explained, so I'm going to explain it just a little bit more. All right? All right, so on the unit circle, you just have to remember your hypotenuse is 1, and then go back to what you know about SOHCAHTOA. All right? My x value represents my cosine, because that is my left and right movement. That's my adjacent. My y value represents my sine. And as long as you know where it ends on the unit circle, you're going to know those values. You're going to know your sine and cosine of your right angle trig. All right? So when you talk about sine and cosine, you're talking about the ratio between two sides of the triangle. When you put it on the unit circle, it simplifies it because your hypotenuse is always 1. All right? And so then you only have to worry about your opposite and your adjacent, or your x and your y. So here's what they've done. They have put a 30-degree angle on the unit circle here. 30-degree angle on the unit circle. This point right here, point P, instead of writing x and y, they've written the cosine of 30 is x, and the sine of 30 is y. So instead of writing xy coordinates, they have just written it that way. Now, here's the thing. A 30-degree angle is a special angle. And so it actually stems from our special right triangles, which I'm sure y'all love those as well. Yes, they are the best, right? And so we have this special right triangle. I didn't draw it perfectly, but you'll get the idea. So if this is 30 degrees, this is 60 degrees, 30, 60, 90. All right, shh. So the guy opposite my 30, even though I didn't draw him very well, is my shortest side. My hypotenuse is always double my shortest side. And this one is always my side times the square root of 3, my long side. Y'all remember that? I know. Sorry. All right, so let's use opposite, hypotenuse, and adjacent, okay, for this guy. So then my sine of 30 degrees should be my opposite over my hypotenuse. S over 2s, which reduces to 1/2. Sine of a 30-degree angle is always 1/2, by the way. Always. Cosine. Cosine of a 30-degree angle should be adjacent over hypotenuse. These cancel. Square root of 3 over 2. That's always my cosine of a 30-degree angle. Always. And so on the unit circle, it is the same. If I were to write my x and y value here, my x value would be the cosine. My y value would be the sine. What does this mean? This means if I were to draw this down, I have moved x units, square root of 3 over 2. I have moved up 1/2. Which kind of looks like it. You can kind of see that I'm about halfway up the 1 unit. 1/2. All right, so let's look at 60. If I were to do a 60-degree angle, opposite over hypotenuse is my sine, and adjacent over hypotenuse is my cosine. So I'm going to draw this in standard position. Here's my 60 degrees. All right. If I want to figure out what my x and y values are, where it ends, I need to find my cosine. Cosine of 60 degrees, remember that's here. Cosine is going to be what? Adjacent. That's an S, right? Over hypotenuse. 1/2. By the way, they flip-flop. All right. They flip-flop. What about sine? What if I want to find my y value? Yeah, what do you think it's going to be then? Those cancel, I get... Right. Because those add up to 90, their sine and cosine will flip-flop. Always. Always. Right. Sine and cosine will flip-flop when they are... complementary angles, right? Complementary angles will always have sine and cosine that flip-flop, always, all right? Does everybody see where they're getting this from? So if I were to put a 60-degree angle on the unit circle, this would be my x value, this would be my y value. If I had it already on the unit circle and I said, what's the cosine of this angle? You could just go straight to your x value. That is my cosine. If I wanted my sine, I could go straight to my y value. That is my sine. It just represents the x and y where it ends on the unit circle. Degree up here. So I put this guy up here too, because this is also a special case that you're going to see. This guy right here. All right. This is a special case as well. If I were to do the sine and cosine of this, I would get side over side square root of 2. So I'm going to get 1 over the square root of 2. I don't leave it that way. What do I do with it? How do I simplify square root on the bottom? Multiply top and bottom by what? Right. So I'm going to get the square root of 2 over 2. I will actually get the same exact thing for those. X and Y value will be the same because it's the same angle, right? So my sine and cosine is going to be the same, and it's going to be the square root of 2 over 2 for that guy as well. So that's one you're going to see a lot. All right, you're going to see that one a lot. All right, questions on that? Let's do these together. Let's do this. No, I don't want an angle. I just want a line. All right, so let's do 45 together. We just did it on a triangle. Let's do it here. All right, we have this. This is my 45 degrees. All right. If we use my special right triangle, we should get square root of 2 over 2. Square root of 2 over 2 here. All right. 30 degrees. We did that one. When I do 30 degrees, I should get square root of 3 over 2 for my x and 1/2 for my y. We got those from our special right triangles. Now let's look at the last one. 120 degrees. How in the world am I going to know what 120 degrees is? Okay, so a 30, 60, 90. Yes, we're actually going to use a 30, 60, 90. Let's look at how. So 120 degrees, first of all, is going to be in which quadrant? We just sketched them. Which quadrant? Second, all right? How far away from my x here? How far away from this 180 am I going to end up being? Okay, 60. So I'm basically going to draw it like right here-ish. All right? Now here's the thing. My angle itself that I'm talking about is this, right? You can use a coterminal angle to figure out your sine and cosine because it's going to have the same terminating point. Terminating point, all right? So a coterminal angle would be going the other way. You can also use what's called a reference angle. A reference angle. A reference angle is the degrees away from your x-axis. So how many degrees away did we say we are from this x-axis? 60. That's going to have the same sine and cosine, or x and y value, as that 120. It's going to have the same thing. All right? So I can actually use this triangle instead. Well, we already figured out a 60 degree, right? We already figured out that a 60 degree has a 1/2 for its cosine and a square root of 3 over 2 for its sine, right? There's just one little difference here. Which quadrant am I in? So my values are going to change by positives and negatives, right? That cannot be the point 1/2 square root of 3 over 2. Why not? It's positive, positive. That would be where? If it were 1/2 square root of 3 over 2, which quadrant would I be in? 1. Which quadrant am I in? So I need to change something. What do I need to change? Yeah, which one's negative? X or Y value? X value. So the only difference between that and just a regular old 60 degree angle is that it's negative 1/2 square root of 3 over 2. Because I am in the second quadrant. And my X values over here are negative. My Y values are positive there. So review, so think about your unit circle or your just your quadrant plane here. X and Y are positive. X is negative, Y is positive. X and Y are negative. X is positive, Y is negative. And so you can use what's called a reference angle. You can use this little guy right here, but you then have to consider what happens to your X and Y values. Find the exact values of negative 120. All right, we just did positive 120. Let's think about negative 120. Let's talk about this. If I were to do my negatives, right, this is negative 90, negative 180, negative 270, negative 360. Which quadrant am I going to be in for negative 120? Third, right? This is 1, 2, 3, 4. All right. Negative 120. So I am going to be about right here. Yes? 90 plus an additional 30. So if I use my reference angle, how far away? So this is my actual angle here that I'm talking about. But how far away then am I here? So the reference angle I'm going to use is 60. We've already done 60. It's going to be 1/2 and square root of 3 over 2, but which order? That's what's important. Which one is my x and which one's my y?
The negative 1/2 is your x, and then your negative, your 2 over 2 negative.
Okay, so
Negative 1/2 is
all right. So every 60 degree is going to be 1/2 square root of 3 over 2. The only thing that's going to change is positive and negative, right? Positive and negative. And if you don't remember, think about where it's sketched. This is obviously lower than 1/2, right? You can see that 60 is going to hit further down than 1/2. So that has to be the square root of 3 over 2, has to be your y value. You can visually see that that's how it's going to be. All right, so the answer then is going to be numeric. You're going to say the cosine of negative 120 degrees is going to be my x value. That's negative 1/2. The sine of negative 120 degrees is going to be negative square root of 3 over 2. That would be your answer. If it said sketch it, you would want to sketch this piece. If it said give the reference angle, you would give me 60 degrees. Okay? So this is sketching. This part right here is reference angle. Okay? So you need to know what it's asking for. If it says sketch the angle, give the reference angle, and then give the sine and cosine. Those would be 3 parts to the same question. How do we do? So sketch it. Your reference angle is going to be 45 degrees. Your x and y value at 45 is always square root of 2 over 2. However, because I am in the second quadrant here, my x value is negative. So that means my cosine is negative. All right. If you were to do exact values, I think it's going to be like negative 0.7, something like that, 0.71. Right? You can do the same thing with a 150. What's going to be your reference angle for a 150? 30. All right? So your cosine is going to be square root of 3 over 2. Your sine is going to be 1/2. All right? Except for a 150, your cosine is going to be negative because you are in the second quadrant. All right? Easy enough.